Okay, folks, I'm on the computer now, and I'm gonna, instead of doing a screencast, I'm just gonna do a straight video recording of the screen. So I think this should work fine. Here's the website for Edis Research. They're the ones that that's make and sell the USRP. This is the one that I bought, the USRP B100, $650. Not bad. They have a bundle here. This is the bundle I got. USRP B100 and WBX for $850. So this is the one that I would recommend if you're looking for an entry-level software-defined radio. If you're looking to do HF ham stuff, there might be better options for you. This will do it, but you're gonna have to add some more filtering. Depending on what board you're going to use, you may have to use a transverter, a nicer RF front end. But for VHF and above, this is a nice solution. Some of their other products, the Network series, a little bit more money. The N200 is about $1,500, and N210 $1,700. I'd love to have one of these, but yeah, I'd rather have a new car. So basically, what you need to do to get your USRP working in Windows is this. Blaine Sieber, and I'm probably butchering his name, but this is the guy that kind of made the USRP awesome in Windows. So in the past, I've been stuck using GNU Radio and Linux. Don't get me wrong, Linux is awesome. I'm a Linux guy. I always use Linux. But this one application, I'm gonna have to say Windows is just better. Blaine Sieber does a lot of work with the USRP and different drivers. He created a plugin, a driver to use the USRP with Windows. He created a software package called the Bohr IP server, which will allow you to stream the RF over IP. He's got a lot of videos on his site. Check them out. I'll have links on my site, digitalham.info. To get started, this is his site. This is his USRP. He puts it in a metal can, so cool stuff. He does a lot of cool stuff. Check out his site. I recommend it. Smart guy. Cool stuff. Go to his wiki and go to download, and you'll download you'll download an installer. It will install the drivers for the USRP. It will install the HD SDR program. Basically everything you need to get going, all in one installation package. There's instructions here on how to do it, and information on troubleshooting and stuff like that. This is the web page for HD SDR, which is the main program I'm going to show you for analyzing signals and stuff like that. Why don't we start HD SDR right now? And it's going to give me shit because I'm creating a video and it never works when you want to show someone. Alright, we're cutting this out and we're going to cue back in. Alright. When you load HD SDR, it will load the ExtIO plugin, and as you can see here, this is for the B100. This slider here will allow you to set your gain of USRP on the fly, allow you to set your sample rate anywhere from 1/4 to 16 megacycles per second. My USB connection, I cannot do over 4 megacycles per second. So I'm limited to an instantaneous transfer 4 megahertz wide. That's fine. That's good enough for me. It would be nice to get 8. I can do 8 in Linux, no problem, no dropouts. If I try to do 8 here, I get dropouts. I think it's just a limitation of the USB subsystem in Windows. 16, wow, that's a lot. I think the only way you can do 16 is if you do 8-bit instead of 16-bit samples, and it's not working in Windows. I'm pretty sure that does work in Linux with the new UHD drivers. So basically I'm selecting 4 megacycles per second. I forget what antenna I'm plugged into, but I'm going to just select RX2. There's 2 antennas, a TX-RX, one antenna port that will transmit and receive, the other antenna port is just for receive. I'm not going to do any networking or anything here. This is all just standalone. So I'm actually going to just close this. go down to the bottom of the screen here. Sound card, what I'm going to want to select is my main audio out, RX output for speaker. AMD, let's see, speakers, high definition out. That's just the sound card on my motherboard. Select OK. Sample rate, 4800 is the sample rate you want for output of the sound card. The input is automatically selected at 4 million from the ExtIO plugin. Got those settings set, and I'm going to hit start. Now, right now, this is a nasty, I got a lot of nasty interference coming from somewhere. Let me adjust the lighting here. Hold on one second. Okay, I think that looks better. Let me focus real quick. Okay, this is 146 megahertz. You have a slider here for your bandwidth. You have a slider here for your speed, your waterfall speed. I really like the waterfall. In Linux with the GNU radio, it has this, but it's not. It doesn't work. It's not as good. It's horrible. I mean, it's nice, but it's more of something that you're gonna. It's just not good. I mean, it's good. Don't get me wrong. It's not as pretty. It's not as user friendly, is what I'm trying to say. Now, what is this nastiness? Hold on one second. I got something, I don't know if it's my computer or I got a real strong source interference here, but I'll show you real quick. Just the 2 meter band. God, that is nasty. Anyway, this is 144 megahertz, this is 148. Everything in between there is what you're legally allowed to have on 2 meters. And what you can do is, see, I see these little white blips here. Let's turn the speed down. I know that's APRS. So I'll wait till I see another one go by. Actually, I'll just go 144.390.000. Type in hertz. Now my tuning is right where I typed it in. I can zoom in if I want. Crank up the volume. And now you'll hear the APRS packets as they are received. There you go. So, whatever. That's just a quick example here. What you can do, let's find some FM. Somewhere around here, I'm sure there's someone talking. Again, I'm getting a lot of nasty interference from something. I'm not sure what it is. Okay. Anyway, that's 2 meters. Looks like crap. I was doing sideband. I had a different antenna hooked up earlier. I was actually listening to some sideband stations on a vertical. So, yeah. And actually, that's centered. It looks like my main interference is centered right at 144 megahertz. I know Ethernet is resonant at that frequency, so I'm pretty sure that's something coming off an Ethernet line or something like that. Let's go up to 440, see if we can hear some audio. There's a strong signal. Zoom in on it. That's a either 438.175. I think that's a remote receive site. And what you can do, oh, they're talking about turbo. think this is the USICO. Here's another analog FM station, 443625. I think that's our Mount Clemens FM. And you can hear that low pitch hum right here. Actually what that is, that's the CTCSS, and I can notch it out by just dragging the filter here. And now that that hum is gone. I think it's a high, it's like a 130 or something. I drag it back down, you can hear it. So I just notch it out and it's gone. Here's some static when I open it up. Let's see. Get that narrow. So it's real user friendly how you can tune, adjust your filter width or whatever. There's different demodulation options. I'm usually using FM. There's AM, lower sideband, upper sideband, CW, DRM. We don't have that here, but whatever. So okay, that's that. This is our 70 centimeters. Here's another station over here, 442175. That's actually KC8 LTS. That's the same station we're hearing, just another rebroadcast of it. Here, maybe we'll be able to hear some DMR. Okay, now I'm going to show you how to decode some digital signals with HDSDR. What you want to do is download a program called Virtual Audio Cable. What this program will let you do is have virtual sound cards in your computer, and you can arbitrarily select one program to input into that virtual sound card and have another program output to that sound card. You got to pay for this. Little hint for people that don't like paying for things like me. There's a torrent out there for it. So just look for the torrent for Virtual Audio Cable. I checked it. There's no viruses, whatever. First thing you want to do after you install Virtual Audio Cable is load the control panel. Run it as administrator in Windows 7, and you get a screen popped up like this. Right now I have 3 virtual cables set up. You can change the number of cables here. I wonder if you can see all that. Oh, whatever. You can change the number of cables here. Probably just set for 1 for starters. If you get more complex, you can set more. Not really self-explanatory what some of these are. Just real quick is your symbol rate, your what am I saying? Your bandwidth, whatever. You set a range from minimum to maximum. I have it from 1400 kilohertz to 48,000 kilohertz. 48,000 seems to be what you want to set it to for doing digital stuff. Your bits per sample. Sample rate. Bits per sample, 8 to 16. Just kind of set as a range. Let the programs accessing the virtual audio cable to give it the option so they don't crash in case they want to choose something that isn't optimal. Number of channels, set it from 1 to 2. That's default. I just enabled mic, line, and SPDIF. One thing you have to click that isn't usually clicked is the volume control here. And this will allow the programs to change settings to the virtual audio cable. Some of the programs will crash if you try to access a virtual audio cable and your volume control is not set. So you load up the control panel, whatever, it's loaded here, exit out of it. Go back into your HD SDR. Now we're still outputting audio to the speakers, so we're going to go to sound card. RX output speaker, you want to select line 1 virtual audio cable. Now we can't hear it anymore because the virtual audio cable is virtual. There's no speakers there. The audio is being sent to it and we're not hearing anything back. To remedy that, to kind of monitor what is going on, go to audio repeater, which is another program that's installed with a virtual audio cable. I think you have to run it as administrator. What this allows you to do here is select your input. Gosh, I should have a camera operator. Ooh, that's pretty. It'll allow you to select your input device and your output device, and you can select whatever you want. So right now my HD SDR is outputting to my virtual audio cable 1, and I want to listen to that on my main speakers, which is HD audio speakers. So I select input, output, and I hit start. Boom, I hear it. But now what this allows me to do, any other program that I want to access that audio stream, I can load as an input device virtual audio cable, which I'm going to show you now. This is 420 megahertz. A lot of the Canadian DMR down here. Nice to kind of test out some DMR decoding programs. Actually, what I'm seeing here, some of this might be images of strong signals because of my crappy Chinese antenna. You want to be careful when you're adjusting your volume here, because this is the volume that you're going to be feeding into the programs. You don't want to overload whatever program you're running. But I'm turning up a little higher so you can hear it. So right there I got an analog narrowband FM channel. Right there I know that's a DMR. That's a distinctive DMR. That's a DMR that's constant. Sounds like it's not going away, so I'm going to say it's a Connect Plus. A Connect Plus control channel. The next program you want to download and install is DMR Decode. Ian Reith, he took some code from a program called DSD and made a nice Java program that will show you what's going on in a DMR stream. I'm going to load that up now. It's a Java program, so you got to deal with Java. Sorry. Sometimes you got to tweak your settings a little bit. A quick thing about gain. You don't want to turn up your gain so high on your RX that you start raising the noise floor. I'll show you an example of what I'm talking about. This bottom line here is your noise floor. These are your signals. My noise floor right now is at about 120 dBm. Our signals are peaking around 60. So we have these are very nice strong signals. There's a lot of range between the noise floor and the signal. So when you adjust your gain here my gain is all the way down. I'm still getting nice, beautiful signal. But what I'd like to do is turn my gain up. That's it all the way up. That brings the noise floor up to negative. That's what's fine. I like to kind of see where the signals start increasing the gain to the point where the noise floor stops raising. Right now it seems like it's raising as soon as I turn it up, but usually around 15 on a nice WBX, 15 to 20 is a good setting for gain. So, since I have such a high gain UHF antenna, I'm just gonna leave it around 10 right now. Drag this down. Now let's pick out one of these DMR streams. What I'm gonna do is I'm gonna zoom in, make sure I have it tuned right on the center, tighten up that filter a little bit, and now we should be seeing one thing. If you're having trouble, one thing that's still kind of confusing to me, at least, is the recording, the default device, and the playback device. With Java, there's no setting in the Java program to select what sound card to use. So you got to go in here and see what. Okay, I got set as default the virtual audio cable. Just kind of make sure your settings are all right. I'm at 4800. There's some debugging. It seems like it's not working right now, but there's some debugging options here. Right now, I can tell you right now, this is not. There's something wrong with the audio cable because this signal, DMR is a 4-level frequency, 4-level FSK, I believe. I might be wrong. And when you're getting a good signal, when you turn on debug mode, you'll see a nice a blip here, 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 and here. Well, I forgot I zoomed in. Sorry about that, guys. And right now I'm just seeing a big blob in the middle, which tells me it's getting noise. It's not getting a signal. So I gotta try and figure out why the sound's not getting into DMR. Let me give a quick pause. Okay, I figured out what it was. Basically, when I was changing the filters to notch out that CTCSS hum on the analog, I forgot to pull that back down, and that was just killing the baseband digital signal for DMR decode. So another thing that was messing up is my Windows volume control. I had the levels kind of. You got to put the levels just to get it right. So right now we got DMR decoding working good. Let's see if I can turn the audio back up just so you can hear what's going on. We'll turn the speakers back up. When you get a good decode with DMR, I'm gonna turn some squelch. This has a nice squelch setting. You can set that right there. When you get a nice signal with DMR decode, you'll see the 4 dots here, 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 and here, and you can see them. You see the data going by and whatever. So looking at this right here, this says connect. I pause it. Connect plus. Okay, so that's connect plus. I'm running out of tape, so I better hurry up. Let's look at some normal non-trunking DMR and let you hear that. That sounds like normal DMR. When you're decoding DMR, DMR decode is great for telling you what group is getting the call and who's making the call. This is another connect. This is actually still Connect Plus. Trying to find a good example of conventional DMR. Right here, group call to group 100,028.1 from whatever. So that's telling you radio ID blah 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 is calling that group. So whenever you go to listen, or you're building your database of what frequencies, what groups are on what frequency, this is how you will pull that information out. Okay, so I'm running out of tape. I'm going to pop another tape in here in a sec. Well, actually, I still have 4 minutes left. Let's decode some audio. What you want to do, go to this horrible site. It's called radioreference.com. There's a program called DSD, Digital Speech Decoder. It was originally written for Windows. Some guy figured out how to compile it on. It was originally written for Linux. Some guy figured out how to compile it for Windows. It'll take you to GitHub. You need 2 programs. It's DSD and MBElib. If you want to compile it yourself. Someone did their own. Someone compiled it, made it exe. All I do is type in DSD, pop up the package. Now I got the program running. So here is the DSD window. Maybe I can zoom in here. This will kind of show us as voice channels or any kind of digital is being decoded, what you're hearing, and it will decode the audio for you. What you need to do is go to your virtual audio cable though, and turn off the that slot from coming back through. And let's see. This is one tricky thing. There's a way to make it so you don't hear the audio, the digital audio, but you do hear the voice audio. Let me figure that out real quick. Okay, I figured it out.
All right, we'll know in a minute if you're at the right address. She'll be coming out to you.
What it's showing us is slot 1, which is actually showing slot 0. Slot 1, you're hearing voice traffic. Our DMR decode will show you what group you're hearing that traffic on and what the radio ID is the source. Real cool for monitoring to DMR since there's no DMR scanners out there. To hear the audio, set your default playback device in Windows. Let me zoom out. Shit, running out of tape. Set your default playback device in Windows, set it to your speakers, and set your default recording device as the virtual audio cable, and that will let you decode DMR.
Georgiana in Warren, Michigan, 12763, Georgiana.
EMS on turbo, nice, huh? Okay, let me pop another tape in and we'll do some more.
Drivers, I have it.
Okay, we're back.
Out by Fremont, going to England Assisted Living, doing 59 minutes. Hamilton will rush picking up by Fremont, going to Eden Rapids, due by 1832.
EMS on the turbo, nice, huh?
What floor is that from? Accent.
Let me turn this down real quick. Okay, so DMR, easy to decode with DSD for Windows and DMR decoder. Over here in Michigan, a lot of the DMR is in between 420 megahertz and 430 megahertz. Actually, 420 and 400. I don't know. We gave away a lot of our bandwidth to the Canadians. I'm going to show you a quick example of just what an LTR trunking system looks like. Let's see if I can change some zoom here. These are your typical. Let me turn up some audio for you real quick with the virtual audio cable. Let's just restart it. Format. Looks like we might have 2 instances of it running. Either way, so let me show you just like a real quick example. Okay, we'll go to virtual audio cable. Turn the audio repeater on. Still doesn't want to work. Sometimes you got to quit the program and start over. Whatever. Right there is that DMR still. There's a analog trunking. Right here you can see from here to here. There's those little pulses, LTR trunking pulses that you hear. And being able to view it like this, you can figure out what order the LCMs are in when you're trying to program it into your scanner. There's a few there. 1, 2, 3, 1, 2, 3, 4. Might be another few there. Whatever. Okay, so that's that. We're at 400 megahertz. Let's go up the scale a little bit, see if there's anything interesting. Some analog. Let's go with a ham band. Some analog audio. Boring. I still get a lot of image noise all over the band. There's something interesting. Now what I would do, if I had a signal I didn't know what it was, and you can check Blank's website for signal analysis. There's a lot of cool tools in GNU Radio that can use to analyze these digital signals. But right now we're just going to do DMR and P25. So, okay, so we're still at 400. Let's slide the frequency up. 450, 460. Right there, I believe this is a high definition television. I believe. Let's see. Sometimes it's hard to tell, but when you see these really wide bandwidth chunks of RF, I'm pretty sure that's high definition television broadcast. Once I bring the whole thing into view, it kind of tones it down. I think that's just because it's averaging out the signal level or something. But let's take a look here. Scroll up some more. 470, 480. That's more interference, I'm sure. 480. There's another television signal. I mean, there's really no need to. Once you have something like this is for monitoring signals. This is kind of like a dream come true. Just having a good antenna, with good feed line is kind of the key thing. This might be another television signal. Not quite sure. Still something I'm learning about. 500, 520. Some noise. 530. 540, 550, 560. What you can do, and actually, to get around with the frequencies a little faster, left click on a numeral and it'll increment it by 1. Right click it, and it'll decrement it. So that's kind of a quick way to moving up and down the frequencies. Let's just go straight up to 800 and see what we can see. Make sure I have my rate antenna turned on. Low 800 is your inputs for your public safeties. So if you're hearing something on there, look out the window because the cops are knocking on your door. There's a lot of GSM, CDMA, cell phone type stuff. I won't get into any of that right now. It's something I'll be looking into pretty soon. But 850 is kind of where it all starts. There we go. See if I can zoom in. Need a camera operator. Where's my pointer at? Okay. Sounds like some digital. I believe this is Open Sky. I'm not sure. Someone fill me in. But I believe that's what Open Sky sounds like. Let's make sure we're going to the virtual audio cable. We can close out DMR decoder. And we'll load up DSD. Because DSD seems to be able to decode. At least the Linux version will decode a few different, besides P25 and DMR, will decode a few other things, but let's go to auto repeater, HDMI. It's another one that sounds strange. You can type these frequencies into radio reference and kind of figure out what they are. Okay, so we got some digital going on here, some digital going on there. Nothing real recognizable as far as trunking goes. At least to my ears. I clicked on this one right here. Let's see if you can hear it. It's kind of quiet, but I know this is a Motorola Type 2, either Type 2 or P25 trunking control channel. And now, once you hear something like this, what you want to do is go to the internet and download a program called unitrunker. This is the home page, unitrunker.com. I'll have the link on my website. Once you get this program installed, load it up. Give me a second. You want to set an input. I'll zoom in here for you. Oops, sorry. You want to set your input as a discriminator and your audio port to your virtual audio cable. Sample rate 4800, 16 bits a sample, mono. That's basically all you have to set. Hit play, boom. Pops up. It tells us what we're listening to. Right there it's telling us that's the City of Warren Public Safety Project 25 trunking system. This is a really nice program for monitoring public safety. So if you're a scanner nerd like me, download this program. There's other programs like it. I recommend unitrunker just because of it has nice database capabilities. what this program will do, will show you right here all the active control and voice channels, and a log of all the traffic that's gone by, like a history log, an affiliation log, radios that logged in or denied, and up here is the, I'll make the font a little bit bigger here, make it a little easier to see. It's a little quirky. The user interface is a little quirky, but once you get used to it, it's not too bad. Oops, I close it out and start it back real quick. Should pop right up. What you do once you get this program running and you're on a system, hit the little steering wheel here, log in with your radio reference username and password if you're dope like me that pays for it. It will download all the talk groups that are on the database for the system. You are then able to access a list of all the talk groups in the system, how many hits each one has had in history. As you can see right here, police, WPD, dispatches had the most hits so far. The water department, fire department, wastewater treatment plant. It will give you an idea of what channels, what talk groups over time are active. Is my battery dying? Son of a bitch. Okay. That's this program. I really like this program. I think it's a good program for monitoring trunking. Another thing you can do with HDSDR is load your frequency manager. Pre-program your frequencies so you can do one click and tune that right in. So let's say I want to tune the gross point. I just click it. Turn up my gain a little bit. This is 800 megahertz coming over 400 megahertz antenna, so I have to turn the gain up a little bit on this one. HDSDR should pop right up, show me all the traffic going by. What I can then do is turn off my audio, my virtual audio cable, turn off the repeater, load up the DSD, I can then click on one of these channels and I should be able to decode. Okay, we got battery power. We're almost done here, but I just wanted to show you decoding P25 transmissions with DSD in Windows. It looked like when I restarted the program, my sample rate went back down to 1200. We turn it back up to 4800. These are real strong ones that are by my house. Just want to. Just a really cool way to listen to.
Chesterfield Dispatch Rescue 2.
I mean, that's decent for.
Rescue 2.
That's a decent quality.
Show Rescue 2 clear the detail and available for calls. Rescue 2, your card.
So, I'll close out the DSD, but this is my entire. This is what 800 megahertz looks like over on this side of town, at least. So there's a lot going on up here. I have a few control channels stored. This over here is what kind of interests me. These channels here. I don't know if this is that open sky or this is telemetry or what this is. If someone recognizes this, I'll give you a quick audio sample of it. Actually, there is no audio. I mean, it's just like flat digital. Sounds like noise. I'm not sure what it is. That's it. Just sounds like white noise. It's data. I don't know what it is. Trunking something? I don't know. But I'd be real interested to find out what that is and how to decode it. And real quick, we'll just do one more. I live close to Detroit, my hometown. They have a very nice trunking system. It's called the City of Detroit Public Safety. Give me a second here. Frequency manager. Here it is on unitrunker. That's a live view right now of every single voice channel. Anyway, yeah, it's a busy system. There's a lot going on here, and they do their best to try to keep their signals in the city, but I use a special antenna to try and pull that in. A lot of traffic in there, a lot of channels. That's 30 channels. This is a simulcast system, so I believe, what off the top of my head, 30 voice channels. A total of 30 channels with control channels. So each site, there's multiple sites. There's 10 different sites. Each site has 30 quanters in it. And that's just the main site. Then there's a backup site. So 30 times 10, that's 300. Oh. No wonder why that city's bankrupt. But anyway, really cool system to kind of monitor with this and just kind of see what's going on. And what I usually do is take the unitrunker, let this sit for a week or something, and you'll see talk groups in the list. If you sort by your hits, go down the list, and what you end up doing, like a lot of the names for radio reference, they're not real descriptive in the way they're formatted here. Like the homicide division, it's not telling you what city or whatever. So what I ended up doing is renaming a lot of these to something more readable. It's a long time consuming task, but it's definitely worth it just to sit here and kind of monitor what's going on. And what I do is watch these hits build up for about a week here, and go down the list. And then boom, there's something that's not in the radio reference database. New talk group, maybe? Plug that in the scanner, listen to it, kind of figure out what it is. Some of these that I've highlighted, like comment 1, that's like narcotics and stuff. So I'll make a special group with that talk group, maybe detectives, go through here and just find some talk groups that are getting a lot of hits over time, put them in a special bank that will kind of like your secret, I don't know, whatever. You get the point. So, real cool program, unitrunker, for monitoring your trunk systems, your Motorola. This also do EDAX. Let me see, I think I got one on here, if I can remember where it is. There's another trunking system. That's Romeo. That's Macomb County. That's North Romeo? No, that's Oakland County. I forget what that is. Jehoiad again. These real strong signals, these white bars that are. God, I'm sorry. I need a cameraman. The really bright white ones. These are ones that are close to my house. That's Macomb County simulcast. Have no trouble getting that one in at all. Your signal level here on a unitrunker, that's pegged at full green. So, yeah. It's like gross point. Anyway, just a fun thing to play around with and listen to what's going on. I'll show you real quickly setting the sound part a little higher, some of the problems it causes. That was 4 megacycles per second. Here's 8. Basically, we just doubled our bandwidth. This big white chunk over here to the right, that's I believe that's Verizon CDMA. I'll move that off to the side. That very first white line to our very right here, I know that's 868.975 megahertz. So that's the highest that public safety is right now. And at our low side here, we're already at 860. So this is real wide bandwidth, but I'm getting a choppiness in here, and I believe it's something that has to do with the windows. And if you see, damn camera operator, our samples being dropped there, overflows. So in Linux it does work, 8 megasamples per second. Windows not so much. We'll go back to 4, hope it doesn't crash, and we're fine. I think next time, my next video, I'll do I'll hook up a better antenna, maybe do some more ham stuff. That's it. That's all I got for you guys. HDSDR, ExtIO plugin from spinch.net. I'll put all these links on my website. DMR Decode from Ian Reith, and unitrunker. All good stuff. Fun stuff. Have fun, guys. KD8EYF here saying, I ain't saving 7.3s. Have a good one. Peace out.